We have just discussed the list object in Python, where we have a list of variables or information, numbers, a list of names, a list of positions, a list of whatever kind of object you want in what kind of data object you have in Python. Aside from this list, we also have a dictionary, in Python abbreviated to dict. A dictionary is also a very powerful tool to store larger amounts of data. The difference is that where in lists we can identify objects by their position, so we have the 4th item in the list, the 10th item in the list, the 100th item in the list, the first or last item in the list, and so forth. In a dictionary, they furthermore have a label, a key to accessing the data. So, for example, we could have a dictionary with information on the party which has a key name and associated a string with the name of the party. And we could have a key X and associated with it a numerical value that is the X coordinate of the party. And we can have a key Y and associated a numerical value that is the Y position of the party. So a dictionary might be a good way to store this kind of information about a party, because we can see immediately what the numbers mean. Instead of having just a name and 2 numbers, we know that the first number represents X and the second number represents I, because we have labeled them. And we can then also access them through the label. So we can call up the X coordinate of the party by calling the variable name and then referring to this X. And then we get the number back that is the X coordinate. Instead of having to say, I want the party list and I want the 3rd object, because I know that the 3rd object is the Y coordinate. Yeah, so one is more robust in programming than the other, because by using names the code becomes more easy to follow, and also when the order changes of the data in the object, we don't invalidate our code. So by using labels, by using keys to identify the items in this data collection, in this case a dictionary, we make the code more transparent, the code more easy to read, and we make it more maintainable in the long run. But the dictionary is not used for what is typically a list. So if we have a long list of names, it does not make sense to have a key name 1 and a key name 2 and a key name 3, etc. Then we're of course back to a situation where we wanted lists, right? So lists are good for long collections of the same type of data. Dictionaries are good for a labeled collection of dissimilar data. Yeah, so a name and an X coordinate and a Y coordinate and a ideology and an age and whatever, they are different types of items. And by putting them all together in one collection with labeled entries, it is easy to look up the age, the X coordinate, the name, etc. But if we have a list of names of parties, then it is easier to use the list and not the dictionary, because we don't have so much labels that we want to associate with them, because they're all the same type of data, but we have a long list of them. Yeah, so in different circumstances, either lists or dictionaries are more helpful. And in quite a few circumstances, the use of them is similar. So we will talk about loops later, and loops can be equally easily used with dictionaries as with lists. I earlier showed you this functionality of making a list of lists. And this way we could keep information together about a single item, like a single book or a single party or whatever we want to collect information on. We can keep it together. So we can make a list for each item and then make a list of lists to keep it all together. There's one big downside of this, and that is that it sometimes gets confusing to remember what each number means. So for example, here we have to remember that the 0th item for any book is the author, and the item at position 1 is the price. And we have to remember this and always consistently use this. This quite easily leads to bugs. It would be nicer if we could say that we are referring to the author or the price. So there is an alternative structure in Python that is a dict structure. So we can do it like this. We can say the author is blue and the price is 10. Yeah, so we can print this, and we can also print the type of this. Let's run that. Yeah, so we find that we have author is blue, price is 10, and the class of this is dict, stands for dictionary. So a dictionary is a bit like a list, but each item has a name, not only a position, but also a name. And this name is called the key. So we have a key, author, with a value blue. And we have a key, price, with a value 10. And this makes it easier to identify specific items. For example, I can do book 3, but get me the author, and it will be blue. Or book 3 and get me the price, and it will be 10. I do not have to remember here that price is the first or the second item. And I don't have to remember that author is the first item. I only need to know that there is an author and there is a price. So this is much easier to work with. And so similar, we can also expand our list of books. We can change this list of books to make it a list of dictionaries. Yeah? So we can have the author is brown, and the price is this price. And then on the next line, author is gray, price is 12. It's a bit more typing. So because we now always have to type in the key as well, this is a bit more work. So that might look unappealing, but the result is code that is much more robust, code that is much less likely to lead to errors because you forgot the exact position. Yeah. So we can still do this, but we can also do call them by their name. Yeah. Oh, I might have made a mistake there. So this is not allowed now. My apologies. I was indexing it like a list and that's not allowed. So we can print the entire dictionary. So this is the first book where we have an author and a price. And we can also print the author field of the first book, and we can print the price of the first book. So this makes for a much more neater organization. Yeah, we are getting less confused about what the data means. This is easier to read than this. And then you still have this index to the zero book and the first book and the second book, etc. But in most applications, you're not actually referring to individual items of the list. Much more common, you have a loop over the list. So you have some while command that counts which book we are and that prints the price. Yeah? We can, for example, say to print all the books, we can say I equals 0 while I is less than the length of books. Print the price of the book by the author is, and then we probably have to use format again, books, the ith book, the price, and the format is this is a floating point number with 2 digits behind the comma. Yeah, and then finally we also need to increase I by 1, otherwise we never go into the next item in the list. So if we do this, we get for the whole list, we get the prices of each book. So here we have a standard loop, a while loop. We first set the counter variable to 0. We then check that we never go beyond the list of the books. And we make sure that we always increase the counter by 1 to go to the next book. And then we can use this I, this counter variable, to know which book we are now referring to. So you get the ith element in the list of books, the ith element in the list of books. And then we can look at the author and the price. This is a very common way, a very good way of using lists and dictionaries. We use a dictionary when we have a small set of items that have a specific meaning, that have different meanings. So the author is of course something different from the price. And we can use these labels to clearly identify which type of information we talk about. But we use a list when every item is of the same type. So here we have these are all books, all with prices and authors. They all look the same. We can use them in the same way. So then we want to be able to loop over it with something like this and be able to use them each time in the same way, like we do here.